All right, here we have a classic problem of a shaded region. In this problem, we're dealing with circles. We've got a non-shaded circle and a larger circle that is shaded. And let's see what they give us. They give us the radius of the big circle is 6 inches long. I'm going to underline that radius because next they give us a diameter, and that can cause issues if you don't pay close attention to those minor details. Radius of the big circle is 6 inches long. Diameter of the small circle is 8 inches long. Might as well just go over here and draw your two circles. So draw a big one, give the radius. They said it was 6 inches. And then with the smaller one, we want to give a diameter, which is all the way across, not starting from the center, and that's 8 inches long. So we have to use our radius when we're finding the area of a circle. So when they give us the diameter, they're trying to trick you, right? They're saying, hey, use 8, use 8. I don't want you to use 8. I want you to cut that in half and use 4. The radius is equal to 4 inches. So we're going to be using 4 inches for that small one, 6 inches for the larger one, and find the area of the shaded region. So if you think about this, if I shaded this entire shape, right? The entire shape is shaded. We can find the area of that. But then if I took this shape's area and just placed it in the middle, we're removing this amount from this total. So we're going to take this total area, and we're going to subtract the area of the smaller one, and that's going to give us the area of the shaded region. So we're going to take overall area of the large, subtract the area of the small, because that's how much space this is taking up, and then we're going to be left with what's remaining. Okay, so how do we find the area of these shapes? Area of a circle is pi r squared. Remember, r is radius. That's why we took an 8 diameter, cut it into 4 inches for radius. Diameter was 8. Radius is half of that, which is 4. Okay, so let's find the area of the larger circle. That's going to be area equals pi, change r to our value of 6. So 6 squared is 36, giving me 36 pi. Now the area of the small, this is the big, area of the small would just be a equals pi r squared again, but instead of r being 6, now we're using 8 cut in half, which is 4. 4 squared gives me 16, so we get 16 pi. Now remember, we want to take the large area, subtract the small area, and that will leave us with the shaded region left over. So we need to take 36 pi, subtract 16 pi. 36 pi minus 16 pi is just going to leave us with 20 pi. Now, if you were asked to round your answer to the nearest decimal point, nearest 10th, 100th, whatever it is that you're being asked, just take 20, multiply it by pi, and that'll spit out that value for you. Okay, right here, I'm going to just keep my answer as 20 pi. That's the answer I would give because that's an exact answer. Keep in mind, if you take 20, multiply it by pi, you're going to get a decimal that goes on forever and ever and ever. So you're either going to need to round that or give an estimate, okay? Hopefully this makes sense. Shaded regions, these are very common problems in your geometry courses. So just learn how to find your areas of basic shapes. And whenever they shade and put the same shape in, you're just subtracting the larger area from the smaller area. Hopefully it makes sense. Study hard and good luck on your upcoming test.